before there was light. Close your eyes for a moment and imagine a time before time itself, before stars burned in the heavens, before galaxies spiraled in silent elegance, before atoms formed, before space stretched, before even darkness had meaning. There was no sky, no distance, no direction. There was no where, and there was no when. What we call the universe had not yet begun. And yet, something was there. Not empty space, because space did not exist. Not silence, because silence requires time to pass. What existed was a state beyond ordinary imagination, a condition so dense, so hot, so compact that every particle, every force, every possibility of everything that would ever exist was compressed into something smaller than an atom. This was not an explosion in space. It was the birth of space itself. Around 13.8 billion years ago, something extraordinary happened. In an instant too brief for the human mind to measure, the universe began expanding. Not into something, but as something. Space unfolded. Time awakened. Energy surged into existence. This moment is what we now call the Big Bang, but the name can be misleading. There was no thunderous boom echoing through a cosmic void. There was no fiery ball expanding into darkness. There was no darkness yet. Instead, there was an unimaginable flash of energy, pure, blinding, fundamental energy, expanding faster than the speed of light in the earliest fraction of a second. This period is known as cosmic inflation. In less than a trillionth of a second, the universe expanded from subatomic size to something macroscopic, vast beyond comprehension, and still expanding. Try to imagine that. Everything you know, every star, every planet, every grain of sand, every breath you have ever taken, was once contained within a space smaller than a single particle of dust. And then, it began to stretch. As space expanded, it cooled. And as it cooled, energy began to transform. Tiny fluctuations, quantum ripples, appeared in the fabric of this newborn universe. Almost imperceptible variations in density. But these subtle differences would become the blueprint of everything. Without them, the universe would be smooth, uniform, featureless. But because of those tiny ripples, matter would eventually gather. Gravity, one of the fundamental forces, began its quiet work, pulling ever so gently, encouraging particles to move toward one another. At first, the universe was too hot for atoms to form. It was a glowing plasma of fundamental particles, quarks, electrons, neutrinos, colliding in an ocean of light. For hundreds of thousands of years, light itself could not travel freely. It was constantly scattered by charged particles. The universe was opaque, like a dense cosmic fog. There were no stars, no galaxies, only a vast, expanding sea of radiation and particles. But expansion continued. And as the universe cooled further, something remarkable happened. Protons and electrons combined to form the first hydrogen atoms. With this simple union, the universe became transparent. Light, for the first time, could travel freely across space. That ancient light still exists today. We call it the cosmic microwave background, a faint afterglow of the universe's earliest visible moment. A whisper from 13.8 billion years ago, still humming softly in every direction. If you could tune an old television to static, a tiny fraction of that noise would be the echo of creation itself. And yet, even after light was free, the universe was still dark. Because there were no stars to shine. For millions of years, There was only hydrogen and helium drifting in vast expanding clouds. Gravity continued its patient work, pulling matter into denser regions shaped by those original quantum ripples. Slowly, almost imperceptibly, the first structures began to form. Clouds of gas grew thicker, hotter, denser, and deep within those clouds, pressure began to rise. When gravity squeezed hydrogen atoms tightly enough, something miraculous occurred. Nuclear fusion ignited. A star was born. The first stars were nothing like our sun. They were enormous, brilliant, short-lived. They burned fiercely, fusing hydrogen into helium, helium into heavier elements. In their cores, the building blocks of future planets and future life were forged. Carbon, oxygen, nitrogen, iron, elements that would one day become oceans, mountains, forests, and you. When those first giant stars exhausted their fuel, they did not fade quietly. They exploded in titanic supernovae, scattering heavy elements across the cosmos, seeding the universe with the raw materials for complexity. With each explosion, the universe grew richer, more structured, more intricate, more capable of wonder. From simplicity came complexity. From uniformity came galaxies. From energy came matter. From chaos came order. And through it all, expansion never stopped. Even now, as you listen, the universe continues to stretch in every direction. Galaxies drift farther apart. Space itself grows wider. The night sky you see is not static. It is dynamic, alive with motion. Every star is a survivor of cosmic history. Every atom in your body is ancient beyond imagination. The calcium in your bones was forged in a dying star. The oxygen in your lungs was born in stellar fire. The iron in your blood was created in a supernova explosion billions of years ago. You are not separate from the universe. You are a continuation of it, a way for the cosmos to become aware of itself. And it all began in a moment without space, without time, without light. In the beginning, there was no sky to look up at. There was only potential. And from that potential, everything emerged. As we move forward in this journey, we will explore how those first stars gathered into galaxies, how galaxies formed vast cosmic webs, and how, in one quiet spiral arm of one ordinary galaxy, a small blue planet began its own story. But for now, rest in the knowledge that you are part of something vast beyond comprehension. A universe that began as a whisper of energy and became everything when darkness began to glow. For a long time, after the first light was set free, the universe remained dark. Not empty, not silent, but dark. Hydrogen and helium drifted through expanding space like invisible mist. Gravity moved patiently through this cosmic ocean, gathering matter where those ancient quantum ripples had left their subtle marks. There were no stars yet, no galaxies, no points of light to divide the night. Only vast clouds of gas slowly thickening under gravity's steady pull. This era is sometimes called the Cosmic Dark Ages, not because nothing existed, but because nothing shone. Yet even in that darkness, change was unfolding. Gravity, the quiet sculptor of the universe, continued its work. Over millions of years, gas clouds collapsed inward. As they shrank, they grew hotter. As they grew hotter, pressure increased deep within their cores. And then, in one of those collapsing clouds, something extraordinary happened. Hydrogen atoms, pressed together with unimaginable force, began to fuse. Nuclear fusion ignited. The first star was born. It did not flicker gently into existence. It roared to life. The earliest stars, known as Population 3 stars, were unlike the stars we see today. They were enormous, hundreds of times more massive than our sun, made almost entirely of hydrogen and helium. They burned at staggering temperatures. Their light pierced the cosmic darkness for the very first time. After hundreds of millions of years without stars, the universe finally began to glow. Imagine that moment. A cosmos that had known only darkness, suddenly illuminated by titanic spheres of fire. These first stars lived fast and died young. Their immense mass meant their fuel burned quickly. In just a few million years, a blink in cosmic time, they exhausted their hydrogen. And when they died, they did not fade quietly. They exploded. Supernovae tore through space, unleashing more energy in seconds than our sun will produce in its entire lifetime. In those violent deaths, new elements were forged, heavier elements that had never existed before. Carbon, oxygen, silicon, iron. The universe was no longer made of only the simplest atoms. It was becoming chemically rich. Each supernova seeded the surrounding space with heavier elements, enriching the next generation of stars. Future stars would form not just from hydrogen and helium, but from this newly forged cosmic material. With each cycle of birth and destruction, complexity increased. Clusters of stars began to gather. Gravity, still shaping the universe on the largest scales, pulled these clusters together into something even grander. Galaxies. At first, they were irregular, chaotic swarms of stars merging and colliding. Over time, structure emerged. Spiral arms formed. Central bulges thickened. Supermassive black holes grew in their cores. Yes, even black holes were born from this era of cosmic fire. When the most massive stars collapsed at the end of their lives, some left behind regions of space where gravity became so intense that not even light could escape. These were the first black holes. Some would remain relatively small. Others, through mergers and steady feeding, would grow into monsters, millions or billions of times the mass of our sun, anchoring the centers of galaxies. The universe was no longer a smooth, expanding fog. It was becoming textured, layered, organized into vast structures. On scales beyond imagination, galaxies began forming filaments, immense strands stretching across hundreds of millions of light years. Between them lay enormous voids, regions nearly empty of matter. This immense pattern is known as the cosmic web. If you could step far enough away, far beyond any galaxy, you would see that the universe resembles a vast neural network. Threads of light and matter interwoven across unimaginable distances. Clusters connected by filaments. Voids separating luminous islands. It is as if the universe developed its own architecture. And within these galaxies, stars continued to live and die. Second-generation stars were smaller than their predecessors, longer-lived, more stable. Around some of them, disks of dust and gas began to swirl. From these disks, something new emerged. Planets, rocky worlds, gas giants, icy bodies drifting in the outer darkness. For the first time, solid surfaces existed, places where chemistry could grow more intricate. Places where, under the right conditions, life might one day appear. But that story was still far in the future. For now, the universe was entering what astronomers call the epoch of reionization. The intense ultraviolet radiation from the first generations of stars began stripping electrons from hydrogen atoms once again, changing the state of intergalactic space. The fog of neutral hydrogen lifted. Space became transparent across vast distances. Light could now travel freely for billions of years. The universe had fully awakened. Darkness had not vanished, for space between stars is still overwhelmingly empty, but it was no longer absolute. The cosmos now shimmered with countless sources of light. Stars gathered into galaxies. Galaxies gathered into clusters. Clusters formed superclusters. And all of it continued drifting apart as expansion carried space outward. Somewhere in one ordinary spiral galaxy forming quietly in a modest region of the cosmic web, a yellow star would one day ignite. Around that star, a small blue planet would form. And on that planet, billions of years later, a species would look up at the night sky and wonder how it all began. But that moment lies ahead. For now, we remain in this early era, when darkness first began to glow, when the universe transformed from simplicity into structure, from silence into radiance, from emptiness into galaxies. And as you listen, remember that every beam of starlight you see tonight is part of this ancient unfolding. The glow that began in the depths of cosmic darkness still continues.